हेलो स्टूडेंट्स, वेलकम टू परमार अकेडमी। हमने लास्ट वीडियो में एपी सीक्वेंस के फर्स्ट हाफ पार्ट को क्लियर किया, जिसमें हमने डिस्कस किया कि व्हाट इज एन एपी सीरीज, फर्स्ट इज द फर्स्ट टर्म ऑफ दैट सीक्वेंस, व्हाट इज द कॉमन डिफरेंस, how to find the value corresponding to a position, and how to find the position corresponding to a value. Now in the second half part, we will discuss how to find the sum of first n terms of series. Means we can find the sum of first 10 terms, or we will have to find the sum of first 100 terms, and so on. We can also find the sum like from term 4 to from 100. For that we will find the sum of first 400 terms. From that we will subtract the sum of first 3 terms. This is how we can find the sum of term 4 to term 100, and similarly we can find another sums. So let's get start. Sum of the first n terms of an AP. Now here we will discuss how to find the sum of first particular number of terms of a AP sequence. So sum of n terms means S1, that is means sum of one term only, that is A1 only. S2, that means sum of the first two terms, that is A1 plus A2. S3 means sum of first three terms, that is A1 plus A2 plus A3. S4 means sum of first four terms, that is A1, A2 plus A3 plus A4. Similarly, sum of n terms means Sn means sum of n terms, that is A1 plus A2 plus A3 plus A4 up to so on up to nth term. Here this is called the sum of n terms. Now we are having the particular formula to find this sum, or also we can find the sum from a particular number of terms. For example, I have to find the sum of third to eighth term, that is A3 plus A4 A5 up to so on up to A8. So I can easily find it using S8, that is the sum of first 8 terms, minus S2, that is sum of first 2 terms get deducted. So using this I can easily get the sum of terms from A3 to A8. Now the formula to find the sum of first n terms is, that is Sn is equal to n upon 2 2a plus n minus 1d. This is the formula. Using that formula we will easily find the sum of first n terms of an AP sequence. So we can also change it like this, n upon 2. We can write 2a as a plus n minus 1 times d. Now look at here, Sn is equal to n upon 2. This is a. Now this is a plus n upon n minus 1d, that is equal to an. So I can write it as also an. So this is the another formula to find the sum of n terms when the nth term is also given. So now let's start with the questions. The first question is, find the sum of a AP 2, 7, 12 up to 10 terms. Here in this question the AP is given, that is 2, 7, 12, and we have to find the sum of first 10 terms. So what is given to us? So the first term of this AP is 2. The common difference D is equal to 7 minus 2, that is equal to 5. The number of terms, 10 terms, that is n is given. We have to find the sum of first 10 terms. And now the main thing we have to find, that is S10, that is the sum of 10 terms. Now we will use the formula, and we know that Sn is equal to n upon 2 2a plus n minus 1 times d. So now substitute the values, that is S10 is equal to 10 upon 2 2a, that is 2, plus n, that is 10 minus 1 d is 5. So now S10 is equal to, that is 5, 2 2s are 4, plus 10 minus 1 9, 9 into 5 45. So this is 45. So S10 is equal to 5 into 45 plus 4, that is 49. So S10 is equal to 245. That means sum of the first 10 terms of this AP sequence is 245. Now I will repeat it again. So the AP is given, that is 2, 7, 12 up to so on. Now we have to find the sum of first 10 term of this sequence. How to find? We are simply having the formula Sn is equal to n upon 2 into 2a plus n minus 1 times of d. Now for that we will find the values. The a, that is the first term, is 2. D, that is the common difference, is 7 minus 2, again 5. And number of terms already given. How many terms we have to use, or we have to find the sum of how many terms, that is 10. So n is 10 given. Now we have to find S10, that is sum of 10 terms. So using that formula, I will substitute the values. S10 is equal to n upon 2, that is n is 10. 10 upon 2 into 2a plus n minus 1d. 2a is replaced by its value, that is 2, plus n is replaced by value, that is 10. 10 minus 1, and d is 5. So after calculation, I will get sum, that is 245. So that's how we can find the sum of n terms of an AP. The next one is find the sum of 34 plus 32 plus 30 up to so on plus 10. Again, the sequence is given. We have to find the term, find the sum. First of all, we will check, is this a AP or not? So very easy. The difference between these two terms, that is second term minus first term, 32 minus 34, that is 2. Difference between third term and second term, again that is 30 minus 32, that is minus 2. So clearly difference between the term is same, that is minus 2. So this is an AP series. Now we have to find the sum of this series, and 10 is the last term. Now look at here. Here we don't know the number of terms. Here this 10 is the value corresponding to any position. 10 is the value, that is 10 is the an corresponding to some position. We don't have the value of n. So first of all, we will find the value of n. So a, what is a? That is 34. D, that is minus 2. An, we have to find the value of n corresponding to 10. So an is 10. First of all, we will find the value of n using the basic formula, that is an is equal to a plus n minus 1 d. Means we have to find the sum of how many terms. An, that is 10, is equal to a, that is 34, plus n we have to find, into d, that is minus 2. So 10 minus 34 is equal to n minus 1 times minus 2. So that is minus 24 get divided by minus 2, that is equal to n minus 1. That is 12 is equal to n minus 1. 1 gets added to this side, that is at 12, that is equal to n. So 13 is equal to n. That means we have to find the sum of first 13 terms of this AP series. So again, using the formula to find the sum, that is Sn is equal to n upon 2, 2a plus n minus 1 time d. Now put the values. We have to find the sum of 13 terms. N is 13. So that is 13 upon 2, 2a. A is 34 plus n, that is 13 minus 1 into d, that is minus 2. Now as 13 is equal to 13 upon 2, 34 2s are 68, plus 13 minus 1, 12 into minus 2. That is equal to 13 upon 2, 68, plus minus minus 12 2s are 24. That is equal to 13 upon 2, 68 minus 24. That is 44. That is 44. Now 13 into 22. that is 13 into 20, that is 286. So sum of the first 13 terms of this AP series is 286. In this question, an is given, that is the last term for the sum is given. First of all, we will find the number of terms that the position of the 10, because we have to use that n in the formula. We can also find the sum using the second formula, that Sn is equal to n upon 2 a plus an. That is equal to n, that is 13. 13 upon 2 a is 34 plus n. N is an, that is an is here 10. An is the last term. We also say that is 13 upon 2 into 44. That is same as this one equation, 13 upon 2 into 44, 13 upon 2 into 44. So using both the formulas, we will get the same answer. But we have to use this formula, basic formula, to find the value of n, because in both these, using both the formulas, we need n here and here also. So we have to use this formula first of all to find the value of n. The next one is if an is equal to 3 plus 4n, show that a1, a2, a3, a4 and so on, an form an arithmetic progression, that is AP, and also find the sum of first 25 terms. Means what is given to us, we have given a generalized form of a sequence, that an is equal to 3 plus 4n. From that general form, we have to find the separate values. So for that, first of all, an is equal to 3 plus 4n. For here, we have to find a1, a2, a3, a4 and so on an. Simply replace n by 1 here. We will get a1 is equal to 3 plus 4 into 1. That is equal to 3 plus 4, that is equal to 7. So a1 is 7. Similarly, replacing n by 2, we will get a2, that is equal to 3 plus 4 into 2. That is 3 plus 8, that is equal to 11. Replace n by 3, we will get a3, that is equal to 3 plus 4 into 3. That is 3 plus 12, 4 3s are 12, that is simply 15. And a4 replace n by 4. We will get a4, that is 3 plus 4 times 4. That is 3 plus 16 and equal to 19. So value of a1 is 7, a2 is 11, a3 is 15 and a4 is 19. Now this is the AP. So required AP is 7, 11, 15, 19 and so on. So this is the required AP. So this is the first part of this question. Now we also have to find the sum of first 25 terms. That is n is equal to 25, because n is not the value, n is the position, and we have to find the sum of first 25 terms. So what is given to us? Simply a is equal to 7, that is the first term. D common difference, that is equal to 11 minus 7, that is equal to 4, and n is 25 given. We have to find the sum of 25 terms, that is Sn is equal to n upon 2, 2a plus n minus 1 times difference. So now put the values. S25 is equal to 25 upon 2, 2 into a, that is 7, plus n minus 1, that is 25 minus 1 into d, that is 4. 25 upon 2, 7 2s are 14, plus 25 minus 1, 24 into 4. This is 25 upon 2, 14 plus 14 fours are 24 fours are 96. So that is equal to 25 upon 2 into that is 110. So that is equal to 25 into 55. So 55 into 25, that is 550, 550 and 225. 1325. 1325, that is the sum of first 25 terms of this AP. So I will repeat it again. First of all, an, that is equal to 3 plus 4n, that is generalized form of the sequence is given, and from that generalized form we have to find the separate terms. Now we have to find a1, a2, a3, a4 and so on. And from that separate values we also have to find the sum of first 25 terms. So simply an is equal to 3 plus 4n is given. First of all, we have to find the separate terms. So for that, for finding the a1, I will replace n by 1. So a1 is equal to 3 plus 4 into 1, that is 3 plus 4 is 7. To find the second term, I simply replace n by 2. So I get 3 plus 4 into 2, that is 3 plus 8, that is 11. And so on, I will find the a3, a4 and a5. Now, the second task is to find the sum of first 25 terms. Again, this is the required AP, that is 7, 11, 15 and 19 and so on. From here, the first term is 7. The common difference is 11 minus 7, that is 4. And the number of terms, we have to find the sum, that is 25. So now again, using the formula to find the sum of an AP, that is Sn is equal to n upon 2 into 2a plus n minus 1 times d. Now I can find the sum of 25 terms. So simply replace n by 25, a by 7, d by 4, and we will get the sum. So that is equal to 25 upon 2. 2 times of 7 plus 25 minus 1 into difference, that is 4. So 25 upon 2, 7 2s are 14 plus 25 minus 1, that is 24 into 4. So 25 by 2, that is 14. 24 4s are, that is 96. 96 plus 14, that is 110. That is cancel out. 25 into 55, and the product is 1325. So sum of the first 25 terms of this AP sequence is 1325. The next one is if the sum of first n terms of an AP is 4n minus n square, what is the first term, that is S1? What is the sum of first two terms? What is the second term? And what is the third term and the nth term? So very interesting and easy question. In this question we are given the sum of first n terms, that is Sn is given 4n minus n square. This is given. So our task is to find the first term, means a1. We have to find a1. What is the sum of first two terms? Means we have to find a1 plus a2, or simply S2. What is the second term? That means we have to find A2 only. Similarly, find third term, that means we have to find A3. The 10th term, we have to find A10. And the nth term is we have to find AN. So in this question, first of all, we will find A1, then A1 plus A2, that is sum of two terms, then the second term only, then third term only, 10th term and the nth term. So very easy and interesting question. So let's start. First of all, as we know that the first term sum of one term, that is equal to first term only. So there is no difference between first term and the sum of one term. So replace n by 1 here. We will get S1, that is equal to 4 into 1 minus 1 square. That is equal to 4 minus 1, that is equal to 3. So this is also equal to A1. So look at here, the first term of the required AP is 3, or the sum of first term is also 3. Our next task is to find what is the second term. Before that, we have to find what sum of the second two terms. Now simply replace n by 2 to find S2. S2 is equal to 4 into 2 minus 2 square. So that is equal to 4 2s are 8 minus 2 square is 4, that is 4. So S2 is equal to 4, that is also equal to sum of first two terms. So we are having the S2, we are having the A1. Now our task is to find A2. So simply look at here, this is the value of A1, that is 3, and A1 plus A2 is 4. Replace A1 by its value here. 4 is equal to A1, that is 3, plus A2. Now 4 minus 3, that is A2, that is 1 is equal to A2. So second term of the AP is 1. Now we are having the second term also. The next task is to find the third term. Before that, look at here, of an AP, required AP, we are having the first term, that is 3. Second term is 1. So here we will easily decide that D, that is 1, second term minus first term, that is minus 2. Now we are also having the value of D. So next task is to find the third term. And we know by using the basic formula of AP sequence that third term is equal to A plus 2 times of D. So that is equal to A plus 2 times of D. Now we are having the value of A, that first term is 3 plus 2 and difference is minus 2. So this is equal to 3 minus 4, that is equal to minus 1. So third term of the sequence is minus 1. The next we have to find the 10th term. Again, how to find 10th term? Simply A10 is equal to A plus 9 times of D. So replace the values. A, that is first term, is 3 plus 9, D, that is difference is minus 2. So that is equal to 3, 9 2s are, that is minus 18, and this is minus 15. So 10th term of the AP series is minus 15. Now the last task is to find the nth term. Now we have to find an, and we know the basic formula to find an is A plus n minus 1 times of D. So that is equal to A, that is the first term, 3 plus n minus 1 into D, that is minus 2. That is equal to 3, 2 is answer, that is minus 2n, minus 1 into minus 2, that is plus 2. So nth term of the given AP sequence is 1, 5, 3 plus 2, 5 minus 2n. So this is the required answer. So this is very easy question, but this question is break into many parts. So first of all, we will find S1, that is equal to A1. Then we have to find the S2, that is sum of first two terms. From that we have to find the second term only. Then we have to find third term, 10th term, and the nth term. So very easy question. This is a main key point. You also have to find D, because we have to use D here, here, and here also. And it is not mentioned in the question, so keep remembering, when we are having the two terms of an AP, we will easily find the common difference, and that is very much helpful to find the another terms also. Now the next is, how many terms of this AP 9, 17, 25 must be taken to give the sum 636? Now again, very easy and important question. In this question, we are given the AP sequence and also give us the sum of the terms. Now we have to find how many terms collaborate to find that sum. Means we have to find the n. How many terms we can use to find that sum. So very easy, simple. So let's start. A, that is the first term, is 9. Common difference, that is 17 minus 9 is equal to 8. Sn, that is 636. And we have to find the corresponding value of n. So we will easily find this number of terms using the formula of Sn. Sn is equal to n upon 2, 2a plus n minus 1 times of D. Now put the values. Sn is 636, that is n upon 2, 2a, that is 2 9s are 18, plus n minus 1, and we have to find into D, that is 8, is equal to 636 equal to n upon 2, 18 plus 8n minus 8, that is equal to 636 is equal to n upon 2, 18 minus 8, that is 10 plus 8n. Now 636 is equal to 2 get cancelled out with inner factors, that is 5 plus 4n, that is 636 is equal to 5n plus 4n square. Now this is simply a quadratic equation, so 5n 4n square 4n square plus 5n minus 636 is equal to 0. Now the whole calculation turns into a quadratic equation. Now we have to solve this quadratic equation using the middle term splitting method or the discriminant method to get the value of n. So we will use the middle term splitting method. Now we have to break 5n in two parts such that the product sum of plus or minus is equal to 5 and product is equal to product of first and last term. So simply that split position is 53 and 48. So that is 4n square plus 53n minus 48n minus 636, that is equal to 0. The middle term splits into two parts. Now from first two terms n get common, that is 4n plus 53, and from last two terms minus 12 get common, again that is 4n plus 53, now is equal to 0. Now these two factors are same, so that means our calculation is okay. Now from the whole equation 4n plus 53 get common, and the next factor, second factor is n minus 12, that is equal to 0. And we know that if the product of two factors is equal to 0, that the first one is 0 or the second one is 0. So from here we will get 4n plus 53 is equal to 0 or n minus 12 is equal to 0. Here the n is 12 and from here n is minus 53 upon 4. We will get two values of n, but n is equal to minus 3 upon 4 get rejected because n is always a natural number, because position is always a natural number, either first position, second position, third position, fourth position. Position can't be negative and the position can't be a decimal number. We can't say that a position is 2.5 or position is 3.5. So simply this value get rejected, so n is equal to 12. This means 12 terms of this AP must be taken to get the sum 636. So this is how we can find the number of terms to find the particular sum. The next one is find the sum of first 15 multiples of 8. Now in this question we have to find the sum of first 15 multiples of 8. First 15 multiples means we have to use first 15 terms that are multiple of 8. Now simply first multiple of 8 is clearly that is 8 itself, the second is 16, third is 24 and so on. We have to find up to 15 terms. So what is given to us, that A is 8, difference is also 6 minus 8, that is 16 minus 8 is 8 and n is 15. We have to find the sum. So what is, how to find the sum? Sn is equal to n upon 2, 2a plus n minus times of a common difference. So we have to find the sum, that is n upon 2 means 15 upon 2. 2a, that is 2 is multiplied by 8 plus 15, n is 15, that is 15 minus 1 into difference, and difference is also 8, that is equal to 15 upon 2 2 8s are 16. 15 minus 1, 14 into 8. That is equal to 15 upon 2, 16 plus. That is 1, 1, 2. 14 8s are 1, 12. That is equal to 15 upon 2 into 128. Now that is equal to 15 multiplied by 64. So the sum is, that is 640 and 320, that is 960. So sum of first 15 multiples of 8 is 960. That is 8 plus 16 plus 24 plus 32 up to first 15 multiples. The whole sum is 960. The next one is a sum of rupees 700 is to be used to give 7 cash prizes to students of a school for their overall academic performance. If each prize is 20 rupees less than its preceding prize, find the value of each cash prize. So very interesting question. What is given to us? So read the statement carefully. A sum of 700 means the sum is 700. So SN is given 700 rupees to be used to give 7 cash prizes. So number of prizes are 7. So that means N is equal to 7. Student of school for their overall academic performance, if each prize is 20 rupees less, means the difference between the cost of prize is 20. That is, difference is 20. Difference is 20 less than its preceding price. Find the value of each cash prize. We have to find the value of each cash prize. So very interesting and easy question. Simply we will use the formula of Sn. First of all, Sn is equal to n upon 2, 2a plus n minus 1 times of d. So what is Sn? That is 700 is equal to n, that is 7 upon 2, 2a. You can't have the value of a, so this is okay. 7 minus 1 into d, that is 20. So that is 700 into 2, 7 by 2 turns into 2 by 7, that is equal to 2a plus 7 minus 1, that is 6, 6 into 20, that is 120. Now 700 cancel out 100, that is 100 into 2, 200 is equal to 2a plus 120. Now 120 gets subtracted from this side, 200 minus 120, that is equal to 2a. 200 minus 120 is 80, is equal to 2a, and 80 upon 2 is equal to a, that is 40 is equal to a. So this is the value of a, that is the cost price of first prize. So cost of first prize is 40, cost of the next prize is 20 more than, that is 60, next is 80, next is 100, the next one is 120, next is 140, and the last one is 160. So these are the 7 cash prizes, in which first cash prize is 40 and the last one is 160. And look at here, their total sum is 170. 40, 60, 100, 180, 280, 400, and 540, and the 700. So total sum is 700. So this is how we can find the amount of each cash prize. So the next one, a spiral is made up of successive semicircles with centers alternatively at AB, with starting center at A of radius 0.5, 1.0, 1.5, 2.0 centimeter, as shown in the total. What is the total length of such spiral made of 13 consecutive semicircles? Now very interesting questions. एक spiral form की गई है. Look at here. Spiral is formed in which this is the first semicircle whose center is A. And now this is the second semicircle whose center is B. Again, this is the third semicircle whose center is again A, and this is the fourth semicircle whose center is B. So now alternatively, this is the next semicircle whose center is A, and this is the next semicircle of center B, and so on. The next one, center A, center B, and so on. Using like that, there are 13 semicircles, and to form that spring, and we have to find the length of total wire used here. So look at here. First of all, the first radius 1, that is 0.5. 0.5. Second radius is 1. Third radius is 1.5. Fourth radius is 2, and so on. Now, as this is a semicircle, so what is the length of wire used for semicircle? That is equal to pi r, because total circumference of the circle is 2 pi r, and we have to deal with the semicircles only, so length is equal to pi r. So for that first is the length is pi into r1, for the second one pi r2, for third one pi r3, and for 13 one, that is pi r13. Now from all pi get common, we left with r1 plus r2 plus r3 up to so on r13. That is equal to pi r1, that is 0.5, r2 1, next r radius is 1.5, next is 2, also on up to r13. Now look at here, clearly the inner one form is a AP sequence, 0.5, 1, 1.5, 2, and the common difference is 0.5. So we have to solve it, that is pi. So what is the values are here? What are the values are here? A, that is the first term, is 0.5. Common difference, that is also 1 minus 0.5. And the number of terms are 13, because we are using the 13 semicircles. So to find that sum, we will use the formula, that is n upon 2, 2a plus n minus 1 times of difference. So that is pi is 22 upon 7, and that is 13 upon 2, 2a, double of 0.5, that is 1, plus n minus 1, that is 13 minus 1, 12, into difference, that is also 0.5. That is equal to 22 upon 7 into 13 upon 2 into 1 plus 12, 0.5, that is 6. That is equal to 22 upon 7 into 13 by 2 into 6 plus 1, that is again 7. So overall, that is equal to 22 upon 7 into 13 upon 2 into 7. 7 get cancelled out with 7, 2 get cancelled out with 22, that is 11. That is 11 into 13, that is 130 and 13, 143. So total length of the wire used is 143 units. So this is how we can find the length of the wire used. I will repeat it again. A semicircle is formed using the semicircles with different radius. First radius as 0.5, second radius 0.1, third radius 1.5, fourth radius 2, and so on. 13 semicircles are used to form that spiral. We have to find the wire used to form that spiral. So simply radius is 0.5, 1, 1.5, 4, 2, and so on. So as spiral is made up of half semicircles, so length of a semicircle is pi r1, second semicircle is pi r2, third is pi r3, and so on, pi r13. Now pi get common from all, we'll get pi into r1 plus r2 plus r3 up to so on r13. And after substituting the values of radius, clearly we will look at here, this is sum of an terms of an AP. So now using the sum formula, we will easily get that total 143 units of wire is used to form that spiral. So this is all about the chapter, that is AP series. Hope so you will like it. Please like, share and subscribe our channel to watch more videos. Thank you.